Welcome to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, well, I'm just going to remind you the 3 books that are on sale. Drink tea and read the paper. If you're a green belt and a black belt and you want simple instruction on how to apply your skill, design of experiments for 21st century engineers, and finally, a statistical process control for small batch production. They are all available from lulu.com and the links are in the video below. Welcome to Complexity Made Simple. My name is Paul Allen and the subject of today's newsletter are the 7 wastes. We're going to go back to lean and look at the 7 wastes, and in particular this is a response to someone that was asking me about the waste of motion and how the waste of motion can be about the product, because one of the things I say is that all the 7 wastes are about the product. So let's take a look at this. So we're going to take a look at the 7 wastes, the 7 lean wastes. By the way, I will remind you, there are only 7. Forget this 8th waste, 9th waste. It is complete nonsense, because these 7 wastes are about the product. So what have we got? Let's go through Tim Wood. We've got transport. We've got inventory, specifically unnecessary inventory. Not all inventory is bad. We've got the waste that we're going to take a look at. We've got motion. We've got waiting. Overproduction. Overprocessing. Of course, my personal favourite, because it's money in your pocket. Defects, errors. Now, one of the things I say is that, and this is to get your thought process right, to get your people thinking in the right way. Because whenever they think of waste, they think of people, they think of productivity, they think what they're doing. And they always say, I'm 100% effective, there is no waste, yeah? When in point of fact, it's the opposite. Most of what you do is waste and there's very little productivity. But that can only be said if these 7 wastes relate to the product. Okay, so, and that's the way I like to put it, even with motion, simply because if we get trapped in the notion that it's about people, we look at the wrong element of waste. We look in completely the wrong places for the waste. And I'm just going to go back to a little example, and I know I've used this before in previous videos. I used to work for a company, Rexel, who made this stapler. We used to make this stapler in the factory that I worked at the time. And one of the things that I became aware of when I was making this stapler was how much waste was in the factory. Because in order to make this single item, this one, if you total up all the work, the pressing, the plating, and the assembly and the boxing, etc., there is only 10 minutes worth of work in this product. Okay, so there's just 10 minutes. So let's put a little timeline up here. And what does the timeline represent? Well, the timeline represents the total time, the material, the product, in other words. The total time, the material is actually inside the factory. And when we worked it out, the material was inside the factory 1 month. And during that time, 10 minutes worth of value from the customer's point of view, because they only value the pressing and the plating and the assembly. Only 10 minutes worth of value was added inside that 1 month. So inside this timeline, there's little slivers of activity that happen to add up to 10 minutes. Let's just put 4 of them in there. And the rest of the time is waste. Now, if I'm going to say to somebody, 99% of what you do is waste, I can't focus on their time. I can't focus on their activity, because they're going to say, yeah, but I'm working for 7.5 hours a day. I'm doing stuff. I'm making stuff. I'm productive. How can you even come close to 99% waste? It's because I'm looking at it from the point of view of the material, and I'm measuring the flow time. And when I measure the flow time, how much of flow time is valuable, how much of the flow time is something else, is waste. So look, 1 month. Well, if you can work it out for yourself, but 1 month, if we stick to minutes, there is 9,900, if we work on 22 working days. 22 working days, 7.5 hour days, 9,900 minutes worth of working time. In that time, 10 minutes got added to that product. There you go, work it out for yourself. Well, I can tell you, that's how much value got added. The amount of time, whilst that thing was sitting inside your factory, the amount of time we added value was actually just 1,000th of the time that it was in there. Now, if I'm going to make that statement, I can't point to people, because they're going to say, yeah, but we were busy. I know you were busy. Customer didn't get the product though. That's the point. Does the customer get the product? So the first thing to say is, that's why I concentrate on the product, because that's how you get the waste measurement. That's how you measure it. So if I concentrate on motion, of course, where's the motion? Well, motion is typically at the point of activity. It's in the green bits, it's in the 10 minutes. You know, so if you've got so you've got an operator, maybe it looks like this. And I've got a workbench. Yeah, and then they've got boxes. I've maybe got boxes of material. Standing on the workbench, maybe. The motion is this bit here, when they're, of course, they're going to build the product here. So here's your motion. So the motion is quite a detailed thing. It's at the point of activity. It's normally in the green blocks. So the first thing I'm going to say, of course, is, why are you going to bother optimizing the green blocks when that's going to do nothing to get rid of waste? Hardly anything at all. I mean, just imagine you had a line balance. So let's say you have a line balance and it's totally out of kilter. Let's say our 4 blocks look like this, and we have a line balance that looks like that. And you say, well, fantastic. If I go and attack the motion here, and I cut that down, what will I do? Well, you know what? I'll double the speed. Well, I'll double the speed. I can halve my number of people in theory, because I'll double the speed traveling through the green blocks. So what you just did was you took your 10 minutes down to 5 minutes. You'll be patting yourself on the back and saying what a fantastic productivity increase you got, and you'll be saying how much money you've saved. Fantastic. Ask yourself this question: what does the customer see? You know what the customer sees? Nothing. I don't see anything. The total time inside the factory is still a month. You've still got, in fact, it's kind of worse now because you've made the value go down, so it's half that, so it's even like that now. So what does the customer see? The customer doesn't see anything. Customer sees no improvement at all. So you can see that I want to concentrate on the big block, and I want to concentrate on the little bit here, the 10 minutes. But even if I did want to look at the 10 minutes, I'm probably going to look at the 10 minutes further down the line, because inventory, waiting, overproduction probably, and because of the others, I'm going to do lots of transportation because my factory's really big. So I'm going to get lots of transport. So I'm probably going to attack the other wastes first. Motion is going to be one of the last things I tackle once some of the big lumps have come out of that 1 month. Maybe when I've got it down to a week, I might think of tackling some motion, but even at a week, still plenty to go at. So this is about the product. It can only be about the product because that's how you measure the waste. I couldn't talk about people. If I told people they were 99% waste, they'd get pretty upset, wouldn't they? But if we say 99% of what happens to the product or service traveling through this building is just queuing, it's just waste, then they get the point and they don't feel personally attacked. But if you tell them that 99% of what they do is waste, they're going to feel personally attacked. Now then, let's still concentrate on this because I want to talk about motion, and I want to show you simple ways, things that perhaps you don't think of how to get rid of motion, and then maybe how motion might play through into a valuable change in your company. How does it change into making more money? Because that's what it's about. Let's take a look at motion and a little bit of some ways of how to get rid of it. Okay, so we're going to take a look at how to remove motion from the workspace, and also how to deliver to the workspace in order to allow that to happen. But also we're going to take a look at, well, where does the money come from? Where does the saving show up? Where's the real money in lean? So we're going to take a look at that in a second. Just before we do, I just want to say that this is more Six Sigma than lean, but if you're into Six Sigma and you want to know all the things that I teach in Six Sigma, my book, Drink Tea and Read the Paper, please buy a copy if you want a little bit of instruction on Six Sigma and how to get processes to be defect free, so that particular waste. Also, please leave some comments below. So if you like the video, if you don't like the video, leave some comments. If you'd like to take the Six Sigma challenge, if you invite me in to fix a technical problem, if I can't fix it, don't pay me. So take the Six Sigma challenge. And if you'd like other topics to be covered in any video, please leave a comment, and if I can cover it off with a video, I'll certainly make one for you and post it on my YouTube channel. But let's take a look at the waste of motion. Now we're going to use an example. This is a real example. I went into a factory that made seats for earth moving equipment. I would call them, in the UK, we have a manufacturer called JCB. So that's typically what we call them. So if you've got a backhoe, you've got a bucket on the front and a backhoe on the back, that's known as a JCB in the UK. In other parts of the world, there will be different manufacturers, but what we're making here is we are making a seat for earth moving equipment. Now sometimes these seats are quite complex. They're sitting on hydraulic and sprung loaded platforms these days. They're not just a simple steel bucket as they used to be on an old tractor. They've often got various kind of levers, and sometimes they've got electrical attachments and things, so there's a lever to be able to turn the seat all the way around and all sorts of things. So they're quite complicated, these things. So we're looking at a production line for making one of these seats, and what we've got here is 5 pallets for the 5 pieces that make up this item. Now the pallets are all 1 meter. That's the way they were delivered to the factory, and then what we've done is we've delivered those to the production line like that and put them on the production line. Of course, in order to do that, I'm going to have to use a forklift truck. Yeah, so it's going to be quite difficult to get these to the production line. Got to have a forklift truck, got to have a forklift driver, got to have white gangways, etc. So we're delivering the 5 pallets to a production line. Now, of course, what we've got then is we've got an operator working to assemble these pieces. So here's the guy's workspace. Now, of course, the smallest this production line can be, the smallest it can be, is 5 meters. Now that's because of the box size, the unit size. So we're talking batch size here. We don't tend to think of the pallet size as a batch size, but it is a batch size. This unit size, we've decided to deliver them by the pallet, and by the fact that that's what we've chosen, what you've done is you've locked this 5 meter size into the production line. So of course now the operator has no choice but to put all this motion into getting the pieces to his workspace and then assembling them together. And to make matters worse, of course, probably what he's doing is he's accessing the components from the top, and as he works his way down so as boxes disappear out of this pallet and the boxes go down and down and down, what's he got to do? Well, he's got to reach in and lift these things. He's working. It's really, really hard. Lots of motion, lots of hard work, very ineffective. Yeah. Now, all we're going to do is just say, let's do something different. I don't want to deliver. I'm just going to change the batch size. Now, the batch size in lean is super important because every time you reduce the batch size, you save money. Every time you reduce the batch size, you get rid of the waste. You compress that 1 month of time down that I talked about earlier. So we're going to do something very simple at this workspace, and we're just going to cut the batch size down. And what we're going to do, we're going to assume that on the pallets, let's just keep it simple. I mean, these would be 3-dimensional, but we're going to assume that there's 16 units on each pallet. And instead of delivering 1 pallet's worth, we're going to go to the warehouse and we're going to pick 1. And we're going to deliver 1 to the point of activity. Now, what does that do? Well, of course, if you deliver 1, there's 5 of these things. You collapse this workspace down. So suddenly, it was 5 meters long. We've divided it by 4. Well, suddenly this workspace, look, 1.25 meters long. How about that? Bang. So, operator, still here at the point of activity. There he is. There's his workspace. Now, look what we've done to the motion. We've destroyed the motion. We've got to have reduced it by 4-fold. We've got to have done that because we've reduced all the distances 4-fold. Okay, so now, of course, one of the things you're going to say, yeah, but I can't, if I go to a forklift truck and pick a single box, that's super wasteful. Yeah, well, that ain't where we're going to deliver it anymore. What we're going to do is this. We are going to go to the warehouse with a simple cart, and we are going to put the 5 boxes on a simple cart. And we're going to wheel this to the point of activity. So now what we've got the 5 pallets in the main warehouse. Yeah, and what we're doing is we're taking a single unit off each one. So of course he's walking down the gangway, bang, box, box, box. Now one of the things you'd be doing, you'd be putting all of these easy to get at down on the floor so that he can just walk down and do this, making it so much easier to get the materials. What else might you be doing? You'd be putting this as close to the point of activity as you possibly can. So this milk round that's going on is as short and as easy as you can do. You don't need forklift trucks anymore. We can reduce the width of the gangways. We don't need forklift trucks anymore. We don't need any licenses. We don't need any training. We don't need any forklift trucks anymore. We don't need anywhere to park them. So the size of the factory is getting smaller. The backup resources are beginning to collapse. What else we got here? Look at the size of the factory now. Before we started, look, the size of the factory was this big. Yeah, and of course it would have had a gangway for forklift trucks, but let's just take the working space. So the working space would have been that big. Now look what we got. The working space is that big. So think about this. We're making more through 75% less space. We're making more because he's going to be making these faster through 75% less space. So 75% of that working space is available to you. And here's where the money is. What are you going to do? You're going to fill it with other production lines and you're going to make 4 times as much money through the same factory. That is where lean scores over every other technique. If you want to, you can work out how much money this saves. You've made this person much quicker over here. There's money to be made, of course there is, but that isn't where the cash is. The cash is in the fact that you make 4 times as much material through the same factory. So all the backup resources and the maintenance people and all the computer guys and all that kind of stuff, got the same amount of people, same amount of factory. You're not heating it and lighting it, not building extensions which are expensive, maybe having another factory which is a mile away and you have to transport between the 2 sites because you haven't got enough room on your current site to extend. All of those kind of costs collapse and disappear, and that's where the money is. So although we've gone for the waste of motion, speed, the operator, that's not where the money is. That's why you don't want to look at your people. The money's not in the people. The money is in the extra service, the extra cash you can get through your business. And that is how lean works. Lean works by making your company make more cash. It doesn't work by just reducing everything to the bare minimum and making everybody redundant. If you do that, it simply does not work. The waste of motion and the power of the box size. The smaller the box, the faster you work and the more money you will make. The power of the 7 wastes.